Excuse me. So today is May 15th. We are starting the kind of last unit, I guess, of the school year, which is going to be energy. A lot of this is going to be review, especially kinetic and potential energy. However, we still have to go over it just to kind of check that box. Um, at this point, I think we have about 12 more school days of actual science teaching, and then we will be getting ready for NCFEs and EOGs, because remember, the last day of actual science content will probably be the June 3rd. Okay? And your science NCFE is the 7th. So looking up here, we're going to look at kinetic and potential energy first. A lot of writing on this one. Just get over it though. Nope. Let's see, I can pull this out a bit. Kinetic. Hopefully you all know what kinetic energy is. It is the energy an object has, the J, object has due to its motion. Okay. Examples: running, walking, talking, breathing, anything that is moving. So essentially moving. Okay, but remember, even talking, your vocal cords are moving. You're still breathing is still, just because you don't actually see the movement. And technically, the electrons in your body are still in all of your little atoms, and atoms make up cells. There's little electrons that are in constant motion. Even if you're sitting completely still, holding your breath, you're still going to have some sort of motion. So that is kinetic energy, energy of motion, essentially is what that is. Time for some more animals. Woohoo! I really like the sticky notes. They're boring. We'll get a little tiger, even though I am moving all the way over here. I don't really know why I needed to add the tiger, but that's okay. Potential energy. If you have the potential, all of you have the potential to do great things. Some of you just choose to be goobers, but that's a whole other can of worms. So, potential energy. I always just think of this as stored energy. All right, it is just stored energy, but a more official definition: energy an object has due to its position. So an object could be living, non-living. A rock, even though it's not made of cells, is still going to be consistent with having potential energy. It has the potential to move. Mechanical energy is actually kind of going to be a combination. But mechanical energy I always think of as kinetic energy, because pretty much that's what it is. But I guess I'll combine these two, or tell our pen at. Mechanical energy is the, there's a little machine spinner. Our camera's been being pretty good lately. The sum of, it's probably going to mess it up when I'm switching pens. The sum of energy associated, bad. Trying to focus it, and I just completely stopped right there. The sum of energy associated with the, fudgesicles, whatever. At this point, goodness gracious. With the motion and position of an object. Hopefully it stays in focus. So it does have to do with motion and position. Now, the rest of these are going to be forms of energy, and how I think of the forms as is Mrs. Chen, and this is how I always just remember it, MRSCHEN, for all 7 types of them. So this would be mechanical, radiant, sound, chemical, heat, electrical, and nuclear. When we talk about forms of energy, Mrs. Chen is just the easy way to remember it. So let's move up to, let's do, mechanical was already done, so this is the M. There's going to be a couple extras on here, and that's okay. But we've already done M, which is mechanical. Let's go ahead and do the R, which is radiant. Okay, radiant energy. Oh, another way that you might see this is light energy. So definitely want to put light on there because it is light energy as well. Okay, so radiant / light energy. So the sun gives off light energy and radiant energy. Light bulbs do this. Television screens, anything that's giving off light. So it is energy carried. Energy carried. And I still think some students are probably skipping ahead. So I'm going to take out... flip him over. Energy carried... Maybe I should just use a sticky note. Energy carried by light and other, let's use a sticky note, by light and other types of, long word, electromagnetic radiation. And examples of electromagnetic radiation, just draw a little arrow, would be UV, gamma, radio, but let's put UV, gamma, of course, X-ray. All right, so of course, that's completely blurry, but, fiddlesticks. What the heck, you butt? X-ray, UV, gamma. Hopefully it'll work. It's being a jerk. Okay, so X-ray, UV, gamma. Of course, I can't even think of the other ones right now, but there's the whole list. Visible light is just a part of the EMS. Yeah, but light is just a little part of it. So looking back at our Mrs. Chen, we've done MR. Now we're on to S, which is going to be sound energy. Sound energy. Penny, don't sing. What do I want to use? I think this one's dying. Let's see. Sound energy. This one should be pretty self-explanatory, but it is energy. You can see that, right? Energy transferred through a medium. For those of you who are like, oh, I don't remember. I know that word. Maybe I've heard that word, but I don't remember what it is. A medium is either a solid, liquid, or gas. It is not plasma. And the reason that I'm saying plasma is so important, is that sound waves cannot travel through outer space. They're a solid, liquid, or gas, so they travel through medium by a longitudinal wave, which is the opposite of a transverse wave. That is how sound is going to move. So longitudinal wave, there you go. Okay, so we've done the misses, mechanical, radiant, and sound. Now we're on to C, which is chemical. Where can I find chemical at? Chemical's all the way up here. I guess I don't need my little animals right now. But chemical. Chemical energy is going to be energy that's stored in the bonds of chemical compounds. It is something that we require in order to live. So chemical energy is energy stored you can read that, right? Yeah, energy stored in the bonds. So what's going to hold different substances together, the different elements together, is going to be in the bonds of chemical compounds. And the bonds of chemical compounds that is released during reactions. So a chemical reaction. So digestion is a chemical reaction. So a good example of that would be digestion. Throwback to the digestive system. Woohoo! oh, your tum-tum is breaking it down. Remember what that chyme is, that soupy mixture? Yeah, it's all a bunch of digested food. And then more is going on. So we've done chemical, now we're moving on to heat. Now in this case, this little one has it down as, I thought I had orange. Do I not have an orange marker, an orange pen? Of course not. That would make too much sense. Thermal is also another word for heat. Okay, I realize you can't really see that, heat. Okay, either way is fine. It doesn't matter which way is written. So if there was some sort of an examination or exam, and you put heat instead of thermal, they would both be completely and 100% acceptable. So it is the energy of an object, due to, so the energy of an object due to the kinetic energy, so it's definitely energy of motion. Heat energy is not going to be a form of potential energy. The kinetic energy of its atoms. Atoms are made up of protons, neutrons, and electrons, or molecules. And molecules is just more than one atom. So H2O is a molecule, while just pure oxygen, pure oxygen is actually a diatomic molecule. There's oxygen's always paired together. Let's say carbon gas, or carbon in general, is just going to be an atom. So one atom of carbon, and that is going to be thermal. So now we've done the H. Now we're on to E, which is electrical. Now, a lot of times when I think of electrical, I'm only thinking of things that get plugged in, but anything that has wiring, so a battery-powered calculator is still electrical. Anything that requires batteries is also electrical, but if it's wired, a car, yes, I guess cars have batteries as well, but it's still going to have electrical components to it. So just because it's not plugged in, that's how my brain always thinks of, oh, it's only the stuff that's plugged in, but no, it is more than that. So electrical is energy made available. Energy made available through the flow of electric current. So electric current does not necessarily mean plugged into a wall. It could be something battery. Electric current through a conductor. We'll talk more about conductors and insulators and whatnot later on in this unit. We are going to touch on electricity and magnetism briefly before you take your NCFE. And lastly, I think we are going to talk about simple machines as well. Maybe like 1 or 2 days of that at most. No, not even 1 or 2 days. I think it's like half a class period. So now we've talked about electrical, which leaves us with nuclear. Oh, nuclear energy. Such a cool concept. In a way, I guess, like the newest energy form, but probably also one of the oldest. Newest in terms of humans being able to harness it. And I use that word harness very loosely, because how much of that energy can we actually control? Who knows? But definitely since 1945, when the first, well, no, I guess so the 1940s, mid-1940s, when the first atomic bomb was kind of tested, that's when we got really a hold of nuclear energy, but nuclear energy also powers the sun. So it is energy released. It's energy released when atoms, okay, they make up everything, atoms split. And this is also fission. We're going to talk a lot more about nuclear energy, partially because I think it's something that's very, very interesting. Some people say it's a renewable resource. In reality, it's non-renewable just because of the amount of uranium, and what the heck do we do with this depleted uranium? But split fission, the fission is how we do power plants. So all that energy that's essentially created from the splitting of a hydrogen atom, because hydrogen atoms have one proton and one, no, they don't think they have any neutrons. They have one proton, one electron. So when you're splitting that, there's an immense amount of energy that's actually released. So split, fission, fission, division, that's how I remember the two of them. When atoms split or join together, which is called fusion. Okay, so when something fuses together, it's joining together, and that is how the sun produces energy. Now, the only way I remember this ever is that there's a U in fusion, there's a U in sun. That's how I remember the difference. So sometimes these little devices, when you U in sun, U in fusion, that's how I remember it. Maybe that'll help you remember it too, like that when you listen to the graph thing, Y to the sky. A teacher, when I was teaching, it was a special education aide, said that, like, oh, that's a kind of a nifty way. So is it kind of silly to say? Yes. But however, it reminds me. It helps me remember. So anything you can do to kind of help yourself remember it. So that is Mrs. Chen. Now, there's two of these, gravitational, sorry, I said that wrong, and elastic. These are both forms of potential energy. Okay? And we will talk more about them, I think, tomorrow. But I'm not 100% sure because I don't even know. So I think tomorrow is what we're going to do. So it is gravitational, has to do with gravity. That makes sense. It is the energy, the potential energy. So the energy of an object due to, I'm going to cover that up. So the energy of an object due to its high position. So something in a plane has a lot of gravitational potential energy. A book held from 1 inch above the ground is still going to have gravitational potential energy, however, it just won't be as high as something like in a plane. High position compared to a low position. So when a baseball is hit and it's high up in the sky, it has the most gravitational potential energy at that point when it's at its highest point. However, as it's coming down, it is going to have the least amount of gravitational potential energy. Its gravitational potential energy decreasing right until the point of when it stops. Okay, last part is elastic energy. If you've ever heard of elastic, like elastic rubber bands or Elastigirl from Incredibles. Elastic potential energy, these are both forms of potential energy. I should probably put that. Potential energy and potential energy. They are both forms of potential energy because it's stored. Whoops. So this is energy stored in an object. So again, it is stored. Stored energy is just potential energy. Energy stored in an object when it is compressed. When it's compressed or stretched. So a rubber band has a lot of elastic potential energy when it's stretched all the way to the end. All right, and that's pretty much the forms of energy that you will need to know.